Deep beneath our feet, buried in rock layers 65 million years old, scientists have discovered something that should not exist. Microscopic spheres of rare metals scattered across the globe in a pattern that mirrors exactly what we see from modern nuclear testing. But these spheres predate human civilization by an impossible margin. We have always believed we were the first species to split atoms, to melt metals, to burn fossil fuels, and change our planet's atmosphere. But what if we were wrong? What if Earth has hosted advanced civilizations before and geological time simply erased every trace of their existence? Today, we journey through evidence that challenges everything we thought we knew about our planet's history. We will explore vanished nuclear signatures, examine mysterious mass extinctions, and investigate why the fossil record contains such enormous unexplained gaps. Prepare yourselves. We begin. Music. In 1980, geologist Walter Alvarez was examining rock layers in Italy when he found something extraordinary. A thin clay band marking the boundary between the Cretaceous and Paleogene periods contained levels of iridium 30 times higher than normal. This rare metal is abundant in asteroids but virtually absent from Earth's crust. The discovery revolutionized our understanding of mass extinctions. That iridium spike became proof of the asteroid impact that killed the dinosaurs 65 million years ago. But what fascinated scientists most was how clearly this single catastrophic event left its signature in the geological record. This revelation sparked a troubling question: if one asteroid impact could leave such obvious traces after 65 million years, what signatures would an advanced technological civilization leave behind? And more importantly, would we even recognize them? The Silurian hypothesis emerged from this thinking. Named after an ancient species from Doctor Who, this scientific theory asks whether industrial civilizations could have existed on Earth long before humans, leaving behind traces so subtle or so transformed by geological time that we simply haven't recognized them yet. Consider the scale of deep time. If human industrial civilization lasted 10,000 years and then vanished, that period would represent just 210,000 THS of 1% of Earth's 4.5 billion year history. Finding evidence of such a brief period would be like searching for a single page in a library containing 4 million books. But evidence should exist. Every industrial civilization must consume energy, alter atmospheric chemistry, and produce waste products that persist far longer than buildings or machines. These signatures become part of Earth's permanent geological record, preserved in rock layers, ice cores, and sediment deposits. The challenge lies in recognizing these signatures. We know what modern industrial activity looks like because we are creating it right now. We pump carbon dioxide into the atmosphere, scatter plastic particles across the globe, and produce radioactive isotopes that will persist for thousands of years. Future geologists would easily identify our impact on the planet. But what if previous civilizations used different technologies? What if they harnessed energy sources we haven't discovered or developed materials that decay differently than our plastics and concrete? Their industrial signatures might be hiding in plain sight, misinterpreted as natural phenomena. The iridium layer proves that Earth preserves evidence of dramatic events across vast spans of time. If the planet can maintain a record of a single day when an asteroid struck, it should also preserve traces of civilizations that might have thrived for millennia. Scientists began examining the geological record with new eyes, searching for patterns that might indicate ancient industrial activity. What they discovered challenges our most fundamental assumptions about life on Earth. The evidence starts with a mystery buried in Earth's fossil record. Earth's fossil record should tell the complete story of life on our planet. Instead, it reads like a book with most of its pages ripped out, leaving behind fragments that hint at chapters we cannot read. Paleontologists call these missing sections gaps, but that word fails to capture their staggering magnitude. The Cambrian explosion 540 million years ago sees complex life forms appearing suddenly in the fossil record as if someone flipped a switch. Before this event, we find mostly simple single-celled organisms. After it, the oceans teem with creatures possessing eyes, shells, and sophisticated body plans. This transition should have taken millions of years of gradual evolution. Instead, it appears to have happened almost instantly in geological terms. The fossil record offers no explanation for this dramatic leap in complexity. But the Cambrian explosion represents just one of several mysterious gaps. The fossil record contains multiple periods where life seems to advance in sudden, unexplained jumps. Species appear, thrive, then vanish without obvious causes. New forms of life emerge fully formed, as if they materialized from nowhere. Traditional explanations point to preservation bias. Soft-bodied organisms rarely fossilize, so we might be missing crucial evolutionary intermediates. Environmental conditions affect fossilization rates, creating apparent gaps where gradual change actually occurred. These factors certainly contribute to the incomplete record. However, some gaps seem too systematic, too precisely timed to result from random preservation failures. They coincide with dramatic changes in atmospheric composition, ocean chemistry, and global climate patterns that suggest something beyond normal evolutionary processes was occurring. Consider the Great Oxygenation Event 2 billion years ago. Oxygen levels in Earth's atmosphere suddenly increased dramatically, poisoning most existing life forms while enabling new types of organisms to evolve. This transformation fundamentally altered the planet's chemistry and biology. Scientists attribute this event to cyanobacteria beginning to produce oxygen through photosynthesis, but the timing and scale of the change seem remarkably precise for a natural process. The oxygen increase follows a pattern that resembles what might happen if an advanced civilization began large-scale manipulation of atmospheric chemistry. Similar patterns appear throughout the fossil record. Periods of stability interrupted by sudden dramatic changes that reshape life on Earth. Mass extinctions followed by rapid diversification of new species. Chemical signatures in rock layers that suggest massive coordinated alterations to planetary systems. These patterns could result from natural processes we don't fully understand. Earth's climate and chemistry operate through complex feedback loops that might produce sudden transitions under certain conditions. But they could also indicate something else entirely. What if some of these gaps represent periods when previous civilizations dominated the planet? Their industrial activities might have altered environments so drastically that most existing species went extinct, creating apparent gaps in the fossil record. The rapid emergence of new life forms might represent either evolutionary responses to changed conditions or evidence of genetic manipulation by advanced beings. The rock layers themselves contain even stranger evidence. Every factory, every power plant, every piece of heavy machinery leaves chemical fingerprints that persist long after the structures themselves crumble to dust.